of a no calculator computation here. Now, this identity is probably the most frequently one used to evaluate something like this. And the reason why it's useful is because, of course, as long as the values are positive, the square root of a plus b quantity squared, this would normally just be the definition of absolute value, but since everything's positive to begin with, we know that this much is true right here. Okay. Now, let's jump in down here and see how we can get to this form. Okay, so it's pretty clear right down here that we're going to have to take A to be 3015. No surprises there. All right, and also, just for it all to fit, see, what's strange about this is that we have these two terms right here, two separate terms, but there's just this single value right here. So we have to somehow or another link up this circled constant here, 36,216, with this entire expression right here. So the circled objects have to be equal somehow or another in order to take advantage of this algebraic identity, okay? And so we can see that just the 2ab term, let me just write it down, the 2ab term okay, would have to equal to, okay, 2 times 3015 would be 6030, right? So this would have to be equal to 6030b for this to work. Again, y'all, it's almost like spitballing. It's not particularly sophisticated. If this is in the form to be a natural number, it has to look like this. Okay. Now, so what does that tell us? That tells us that it would be a good idea to divide 6030 into 36,216. So, and this actually isn't a difficult computation to do just by hand. So 36,216. If you divide 6030 into that, the division algorithm and just a little bit of mental math will give you 6 times 630. Okay, 6 times 60. Here we go, 6030. Okay. Now that's 36,180, but then you would have a remainder of 36 upon that calculation. And you guys can verify that. Get this, I'm running out of room again. Okay, so this is 36 right here. But a nice thing happens, and a lot of you have probably already seen this, but that's 6 squared, right? Okay, so you see it's fitting our form very, very nicely. That means our b is going to have to be 6. And we can write this as, down here, we can write this as the square root okay, we can write this as the square root of 3015 squared okay, plus 2 times, y'all may use the dots here, 2 times 3015. Two times 3015, and then times the 6 that we just discovered in the previous step. Okay, let me extend this radical symbol. Okay, so that'll be times 6, okay, plus 6 squared. Okay, that worked out nicely. Okay, that's exactly this form up here. But notice that just means that this reduces to the form we were striving for. A little bit more space there. So that would be, just by the binomial squared identity, okay, 30, 15, oops, 30, 15 plus 6 30, 15 plus 6 quantity squared. Okay. And so again, square rooting and squaring your inverse operations. So your final result here would be 3021. And y'all, you may be able to use the difference of two squares identity to pull this off also. But anyway, it works, and you kind of have to game these things. Normally, a problem like this is designed to work out nicely. If it didn't work out nicely, you would end up, with just a radical or an irrational number solution. Okay, so they're usually designed to work out nicely, so you can expect one of the well-known binomial identities, the difference of two squares, or a plus b quantity squared, to work out for you. But anyway, that's it. Let me know what you thought. Hope you enjoyed it.